Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are bringing to you on all the areas in science. And today we are here to do chemistry, that is organic chemistry. We are continuing with the calculations. In our last video, we did one calculation on the empirical formula determination. We are still going to take you through another calculation. Now, there is a question. It says that a sample of poisonous compound nicotine extracted from cigarettes which people smoke was found to contain 84% carbon, was found to contain 74% carbon, 8.65% hydrogen, and 17.3% was nitrogen. What is the empirical formula of the compound? Now, nicotine is a poisonous compound where it is found in cigarettes, and still people smoke the cigarette. And so we are going to find the empirical formula, that is the smallest ratio of the atoms of the elements within the compound. So we are going to find that. So quickly, solution. Let's write the solution here. Solution, underline nicely. And then quickly you write the data, that is the percentage of the various elements there. So the percentage of carbon, you write it as what? In the question they gave what? 74%. That is this, okay? And then write the percentage of what? Of hydrogen. In the question they gave what? 8.6 5%, okay? And then they gave they say nitrogen, okay? Percentage of nitrogen is what? 7.3%, 17.3%. So these are the percentages. Now once you write that, quickly sum up the percentages. I beg, when you finish that, sum up the percentage. This is very important because it might beat you, okay? Sum up the percentage of all the elements and make sure that it's up to 100, else you will get wrong. If you don't do that, they can trick you and you always get something else, okay? So sorry, let's go back a little. That's the percentage of nitrogen, and write the percentage for nitrogen, 3 elements, and then check it whether it is up to 100, okay? So quickly let's do that. We are going to get 74 plus 8.6 and plus 17.3. Let's check whether they are up to 100. If it's not up to 100, you find the missing percentage, okay? You find the missing percentage, okay? So quickly let's check. Go. So when you add all, you are going to get close to 100. So that means you take it equivalent to 100. Okay, so that is it. So you take it, close to 100. Now, so once you do that, that means that, okay, you have gotten the confirmation. That is, it's almost 9. Okay, when you do that, this one will be almost 9. Okay, 95.95. Okay, 95.95. The question, okay, gave it very clear that it was found to contain this, and that. Okay, so that is it. Now the small percentage, okay, we tend to know to forget it. Already, nicotine is not containing oxygen. Nicotine doesn't contain oxygen, so you don't include that inside. Now, so quickly let's continue. So once you do that, okay, you now write the formula. So here you write the various elements that are there. Okay, write the various elements that are there. Here we are going to get the percentages. We are going to get 74%, and we are going to get 8.65%, and then you are going to get 17.3. Now then you find the what? Next is to find the what? The mole. Okay, next is to find the mole, okay, by dividing by the relative what? Atomic mass. So here you find the mole. Here is divided by 12, and here is divided by 1. Here is also divided by what? By 14. And here you are going to get, here you are going to get the first one to be 6.17. 6.17. The next one you are going to get the same thing. It's 6 point this, and then the last one you are going to get 1.24. Now once you get the ratio, I told you the next is to what? Is to further divide the ratio. So that is to find the relative mole, that is to find the divide it again. So divide the mole. So you find the mole, and then you divide the mole for the second time. So the first, the mole you got was what? So carbon, you got the mole to be 6 point, got the mole to be 6.1 what? 7, and here you got the mole to be 8.65, and here you got the nitrogen to be 1.24. So the next is to what? Is to divide the mole by the simplest. That is, what is the smallest number here? Is it 6.17? Is it 8.65 or 1? This is the smallest number, so you divide all throughout by the smallest mole. Okay, divide by the smallest mole, divide by the smallest mole, and divide this one by the smallest mole. Divide some by the smallest mole. So you do that. Okay, so when you do that, you will get the ratios to be 4.98. Calculator will not deceive you. And then you get 6.98. okay, and then the other one you get what? 1. So this is the mole. So this is the simplified ratio. So here become the simplified, what? Simplified what? Ratio. Now once you get the simplified ratio, you just round it up. Okay, just round. Okay, round up. Okay, round it what? Round it up. So here this is very close to 5, that is above 5, very close to 5, that is 8. So you round this one, add 1 to it, you are going to get 5. But the decimal here is above 5, that is 9. You round it, you are going to get this, and here to you round it, you are going to get what? When you round it, what are you going to get? You are going to get 7, and here is still 1, so it's still 1. So actually the formula, the empirical formula that we are looking for, you then write it. Write the empirical formula you are looking for. Okay, so the empirical formula consists of what? 5 carbon and 7 hydrogen, and then what? 1 that. So that is the empirical formula. So basically, so that is the empirical formula. So basically that is it. So what all you do is that you read the question, you write the percentages there, and check whether the percentages are up to 100. If they are not up to 100, now check the compound, whether the compound originally contained oxygen. If the compound doesn't contain oxygen, as nicotine for example, there's no oxygen in nicotine, so you just use the element there. Most compounds contain oxygen, so usually you can you put the oxygen there, but here nicotine do not contain that. So you do that. Now here the question gave you that they gave you that they are 1, 2, 3. Okay, so here I think the percentages here, when you add all the percentages, this one. Okay, they didn't do the percentages very well. They should have done the percentage in such a way that it is up to 100, because it doesn't contain oxygen, so they should have done that. So that is not it, but this is just a test case that we are using to show you how this the formula is. It must always be equal to 100. Okay, it must always be equal to 100. Since there's no oxygen inside, they must always be equal to 100. Yeah, this is not up to, when you add all, it's not up to 100. It is 0. It's 95 point this one. So that is the percentage. That's the percentage that we took. So that is it. But the last one is that please always add it up to what? It must always be equal to 100. If it's not up to 100, there is something missing. Okay, read the question very well. Whether the compound contain oxygen. If the compound doesn't contain oxygen, still progress. But in that case, you will not get something less than what? 100. So when you do that, you first write the percentages there as I've done here, and then you find the mole, because I told you that percentages, okay, is done in terms of masses. It is done, percentages are in terms of mass, and so mass over molar mass is mole. So you find the mole next. Once you get the mole, you get a ratio, and then you further divide the mole by the smallest number. So here the smallest number was this. You divide all throughout by the smallest number. And then when you divide throughout all by the smallest number, you then continue, okay, to write the decimals, and then you round it up to the integers, and then that becomes the empirical formula. So we'll end the lecture here, and in our next video we would continue with the elucidation of the organic compound. Thank you.